up until now, when we've been looking at derivatives, we've been looking at gradients, yes? And all of our functions have either started off with a y equals, and they've been involving x, or it's been fx. So they've been in function notation, or it's been y, but they've been involving x's only. Now, this sheet here, and there's not a lot to write on this one, but essentially it's just letting you know that when we're differentiating, we're actually finding the rate of change of things. And that's what gradients are all about, how the y values are changing as the x values are. So the letters being used will not always be x and y when differentiating. This is because calculus is used for graphs, for practical situations, and not just functions. Okay, the derivative is finding the rate of change. So if you see phrases like rates of change, that's what you'll be doing. You'll be finding the derivative. So it's the rate of change of one variable compared to another. In these cases previously, it's been a change in y and the value of x changes. So that's why we've been writing dy dx, because we're looking at as y changes as x changes. But we may want to look at other variables such as speed and time, or distance and time, or area and radius. The list is endless. Okay, so there's lots and lots of different options. Don't panic too much. Essentially, most of the time you'll be only seeing things in x and y, or in the distance and time thing that we're going to be looking at in a second. If other variables are used, the method of differentiating is the same, but you're just going to use different letters. So, for example, what is a equals pi r squared? What's that? A equals pi r squared. Area of a circle. Yes, so the area of a circle is obviously going to change if the radius changes. The smaller radius, the smaller area, the bigger radius, bigger area, yes? So it tells us the area of a circle of radius r. If I was to find the rate that the area changes as the radius changes, then all you would do here is find dA, dr. Okay, so you would just be using different letters at the back of it. Does that make sense? Yeah? How would we differentiate dA, dr? Okay, so I'm looking at this expression. I'm focusing on my r. Well, I'm going to ask you first, what's special about pi? Does it change? No. No, so essentially that's like having a number there, yes? Yeah. All right? So dA, dr, Leonate, do you want to that match?
Is it for pi to r?
Yes, secretly we'd normally put the numbers first. So it would be 2 pi r.
Yeah.
Yes? Easy peasy. Power comes in front, take one off the power. And as I said, the pi, because that's a constant, it doesn't, it just stays there within our writing. Okay. You should also recognize that. Yeah. Alright, so next page. So kinematics. So in calculus, there are two main options that you're going to see. Either it's going to be a straightforward function that you'll be able to differentiate or find some information about, like turning points, maximum, minimum. Or there'll be a kinematics question. Okay. Now, kinematics is the study of movement, and we use calculus to link the distance, the speed, and the acceleration with the variable of time. Okay. So we're looking at distance and time, speed and time, or acceleration and time. So there'll be expressions or formulae given to you for either the distance, the speed, or the acceleration. And the variable that they will be using is always going to be t for time. Now, distance is assigned the letter s. It's actually displacement, if we're getting really fancy. And those of you that do physics, there's people, I don't know what's going on with what's saying. Okay, so the distance travelled is equal to the displacement, and that's given s. The speed, again, that's another secret situation. That's actually the velocity, which is given a letter v. And And the acceleration is the only one that we pretty much think is normal, and that's given the letter A. That's you. So we have S, we have B, and we have A. And as I said, they'll all be given to you in terms of T. So, for example, they've told us that S is equal to T cubed minus 4T plus 5. In other words, to find the distance the particles moved at a given time, you're going to cube it, take away 4 lots of the time, and add 5 to it. Okay, so that's just the expression that they've given you. But the link to the distance speed and acceleration is that if we differentiate this expression here, so if we differentiate S, that would be finding ds dt. That actually, I'll write it here. That would be finding ds dt, and that's actually equal to the velocity. So the expression for ds dt, the derivative, gives you the rule for velocity. What do you think it will be happening for the acceleration? It's not true. We differentiated this one to get to this one. We're going to differentiate this one to get to this one, yes? So that will be dv dt gives us the acceleration.
Hey, why is that? Is that just like, I think
It's just
because of
well, yeah. I mean, it makes sense that as when we talked about distance time graphs, we were talking about the height of it, like the height of the thing shows it going at faster speed. And so the link is there that if you're finding the rate that the distance is changing with respect to time, then that must be talking about the speed of the object. Yes, and then acceleration again, if you're going faster, it means your acceleration is increasing. So it does all make sense. The trickier thing is that in your exam, if they you see a question about distance or displacement, speed and acceleration, then people often like, oh my gosh, they get confused as to whether it's a calculus question or whether it's a distance time graph question. Essentially, normally later on questions are to do with this. If you haven't seen any other question about calculus, then it's going to be kinematics. Okay. So it says here, if given an expression for the distance and asked to find the speed, you must first differentiate the expression and then substitute the value of t. So if they gave you, have I got an example?
Yeah.
All right, so here we go. The distance m of a particle is given by the blur. Find the speed of it 4 seconds after it started moving. For a start, what do we think this m is? Meters. Okay? So sometimes when people start seeing stuff in brackets, they start freaking out. This may also be given like this, st equals t cubed minus 4t plus 5. So they may have given it to you so it looks like a function, okay? In a similar way that we've seen fx, they may write st. Okay, so just be aware of that. Because again, I've also seen people try and do something with this t here. Okay, you're only interested in what the expression is equal to. All right. So we know that s is equal to this, but they've asked us to talk about the speed of the object. Okay. So because they talked about the speed, it means we now need to differentiate this expression. Okay. So Emma, how would I differentiate this expression?
3t minus 4. Oh, 2, sorry. Minus 4 and then 0.
Okay, yeah, I'm going to just do that, yes? So we're all happy with that? 3t squared minus 4? And they've asked us to find the speed 4 seconds after it started moving. So if it's 4 seconds after it started moving, it tells us that t is 4. And so we're just going to substitute that value into this expression we've got here. So that would be 3 lots of 4 squared, take away 4. We have to remember we need to use their maths. So we're going to square the 4 first. which is 60. Multiply that by 3, which is 48. Take away 4, which is 44. Now, the units are going to depend on what distance and time we've used. So, what our distance said was which unit, and then what the time unit was a. So this is going to be meters per second or ms minus 1. Either of those two would be acceptable. So in a similar vein, if they'd given you an expression for the velocity and asked you about the acceleration, you would have differentiated. If they continue this question and they've given you this displacement and then asked you about acceleration, you would have to differentiate first and then differentiate this expression for the next for the acceleration. Okay? Any questions about that? So the process itself is the same. It's just the application of it is slightly different. Okay?